start about clean code, or cleaner code at least, for large-scale legacy applications. In the about-ish 12 years of my career, I had like 3 different, sections. The first one, I was working with legacy code, but I didn't know anything about clean code. So ignorance is bliss, right? Then I learned about clean code, and I still was working with legacy code, which became a bit of a problem, but basically became the foundation for this talk, for my blog, for everything or mostly everything I'm doing right now. And then, luckily, at some point I got away from the legacy application. I'm still trying to write some clean code at least. Since this is about a few of the experiences and lessons learned of that second part, and I was dealing with C++ applications mostly, this will be a bit about C++ legacy applications, but I think most of this talk will be usable in other languages as well, since I won't be talking too much about the language themselves. So this is quite a mouthful of words, so what do I mean by these? Legacy C++ applications. I mean, this is the wrong one. So what do I mean by legacy? What's the definition for legacy code? We had a few talks about legacy code already. I think the best known definition of legacy code is by Michael Feathers. It's code without tests. I would maybe add that it's also code grown over the years. So when I speak about legacy code in this context, I'm not speaking about code that has been written 10 minutes ago but has no tests yet.
Kate Gregory puts it quite well. She calls it code that you're afraid to change.
Yes, it's pretty good code that you're afraid to change. So maybe also includes old style code, maybe code that is running or is compiled with an old compiler and doesn't have the new features. But I wouldn't include that because you still can write pretty good code and very well tested code when you're still stuck with like older C++ standards, for example, C++ 98 or 3 or something. Older code, I include older code grown over the years because we often do not remember the rationale why we wrote something the way it's written. Very often even the original author is not present anymore, so we can't even ask them why they have written the code in the way they did. But I think the afraid to change includes all that, right? There's a quote by Bjarne Strustrup. Legacy code is a term often used to characterize code that is written in a language or style that the speaker-writer considers outdated. Yep. Is competing with something sold, promoted by the speaker. Well, I want to promote clean code, so yes. But the important part is legacy code often differs from its suggested alternative by actually working and scaling. So we have to keep that in mind. I think this is a really important part because I've a lot of times seen people just jump ahead and say, well, this is old style, you shouldn't use this, just go ahead and change it and like use all the shiny new features, and suddenly it either doesn't work anymore or it doesn't scale anymore or the performance degrades. So we really have to know why we are actually changing the code. So what do I mean by large scale? I mean, depending on who you ask, large scale can be something very different. I've talked with a few colleagues who are doing like JavaScript, web development, and for them large scale was anything about 50,000 lines of code. In those first years, the large-scale applications I was working with were like 3, 4 million, maybe 20 million sometimes. So this is what I would consider large scale. I know there are much larger applications. There are also smaller applications that are hard to deal with, that are legacy code. I mean, it also depends on the size of your team. If you're alone, 200,000 lines of code is a pretty big project to maintain. So the problem with these large-scale applications mostly is you can't sit down and just work from first file to last file and clean it up in a week or in a month or so. So what does this have to do with legacy code? Does anyone recognize a city? Yep. Well, it's a photo taken from Wikipedia. It's Dubrovnik, or as some people call it, King's Landing. This is a legacy city. It's grown over the years, over the decades, over the centuries. And if you look at this photo, you don't really see much structure, right? This might be go on and on for miles. And if someone just took you and dropped you somewhere in there, you had a really big problem because you wouldn't know your way around. Every corner maybe looks slightly different, but you don't see any major avenues or something, so you don't know where to go. So if you've seen Jonathan Boccaro's talk about the 10 tricks to navigate like a legacy code base, this is where it would take off, and then hopefully know parts of the system, but it's really hard to know all of the system. I mean, you could go around here with Google Maps, but usually one of the attributes of a legacy code is, well, that the map in there, meaning the documentation, is not very good or outdated or doesn't exist at all. So when I talk about clean code and C++, especially to non-C++ developers, that seems to be a little of a contradiction. Because they say, well, C++ is so messy, it's so low level, and you have like all this bit operation, and don't get me started on pointer arithmetics and so on. How can you write any clean code in C++? It is possible. You can write clean C++. It's not only that modern C++ standards provide features that allow you to write cleaner, like, for example, range base 4, which isn't a mess of something, colon, iterator, auto, something, but just a range base 4 short loop. You can also write cleaner C++ in C++03, so it's no excuse saying, like, I have an old compiler, I can't write clean C++ or something. Some people say, I've read the book, the clean code book, but there's nothing about it what we can use in C++, and it isn't even about C++. It's not about C++, it's using Java, that's right, but the principles that are in there, you can use them one-to-one in C++ as well. It's about having short functions, having good names, having like single responsibility for classes and functions. That's nothing you cannot do in C++, so it's clearly possible. So the book, while it uses Java for examples, is pretty much language agnostic. Those are a few of those principles mentioned in the book, and which you can use everywhere. Keep it simple and stupid, so the simpler the code you write, the more maintainable, understandable it is for everyone else who is reading it. Then there are the solid principles, which are mostly, but not only, for object-oriented programming. So the single responsibility principle, open-close principle, meaning your code should be open for extensions but closed to change. So if you want a new feature, you usually write a new class and don't ram the feature into something old you have already. Interface segregation principle is the I forgot the L, list of substitution principle, which is clearly object-oriented. Dependency inversion, and DRY is don't repeat yourself. People often say don't repeat yourself is only about don't copy-paste your code. But it's also about having a single source of truth, meaning if I do like an interface or some communication protocol, then I want to have one single source where this is defined, the communication protocol is defined, and I don't have to, for example, re-implement everything, my database definition and the objects I put into the database and some transport protocol where I have like 3 times to implement the same stuff. I want maybe to generate even the database definition, data object definition, and so on. So we should make use of the C++ features that make the code more readable, more reliable, more secure. For example, as I said, range-based for smart pointers, RAI classes in general. But we can also use, well, older features. Well, I mentioned RAI. If you don't have smart pointers, we maybe can write something like a smart pointer ourselves. We can use strong types. We can use standard algorithm. And if you say that to someone who's been, well, using C++ for a reason, and not only for the reason that back then when they started the project there was no Java and C#, they tell you, well, but what about performance? A lot of the people I've worked with were like, yeah, we are writing C++ to have a performant language, so we have to write performant code. So we have to manually tweak the code the way we think is most performant. Very often we have like ancient lore, ancient myths about you don't use early returns because early returns is bad for the performance. So we use like all those indentations and then a single return at the end. And those are really ancient myths that maybe had their justification in the 80s, but not today anymore. I mean, modern optimizers can really well see what you're doing in the code, especially if you have like easily readable structured code, because they know the usual patterns we use. So when we go ahead and try to manually tweak the code to something we think might be more performant, then there's a good chance that modern optimizers might not see those general patterns anymore and actually stop optimizing the things they would have been optimizing before. Performance is important. The other thing is we don't need to have the best performance in every single part of the code. When we are starting our program, we are starting it once. And if it takes half a second or half a second and 500 milliseconds, or it doesn't really matter that much. What we want is the performance in the performance-intensive part of the code. And before we go ahead and manually optimize those parts, we really have to see, first of all, use the right data structures and use the right algorithms, because if you have an algorithm with exponential complexity where we could use one that goes like n log n or something, we can do the best performance tweaks we want. If you get more data, the thing will go really long instead. And if we instead use better algorithms, we gain more than we can gain with any performance tweaks. We should, in the first place, try to trust the optimizer. They're getting better every year. If you can, you really should try to see the YouTube video from CPP on C from the keynote from Matt Godbold. I mean, this is probably one of the few talks in this conferences where I do not fire up Godbold and show you something, but he has a whole talk where he shows like you put in some really complicated code and the optimizer just goes ahead and optimizes it all the way to a single instruction. So optimizers are really good, we should trust them. And then we should find the actual bottleneck. If we have like the feeling that our code is slow at some point, we should not just go ahead and try to optimize all the points in the code we see. We should try to find the actual bottleneck and then try to optimize there. And after we manually optimized, you should check if we actually have optimized anything. And use a profiler for this, for both of this. A profiler can show us the bottlenecks where we spend most of our time. A profiler can show us whether the things we have done to the code actually made the code faster or not. So the bottom line is try to write well-structured and clean code by default, and after that, see if we have to optimize the code. That doesn't mean that you should write like this is not about like pessimizations. If you see pessimizations in the code, you have to get them away, of course, but you shouldn't try to manually optimize before. So back to large-scale legacy applications. If you want to clean up the code of those large-scale legacy applications, means we have a huge code base, we want to clean it up, while at the same time people will be modifying the code base because they want to fix bugs, they want to add new features, and it's a huge fight, and we cannot fight this one alone. So we need the team on our backs. Because the worst thing you can do is like try to fix things alone, and then the team goes ahead and does things like they have done in maybe like the last 5, 10, 15 years. And you're basically not only fighting the code base, you're also fighting the team. And you can't win that fight. So if you have legacy code now, it's because we have let it happen in the past, of course. That can be because we didn't know better. We can remedy that by training, by practice, by getting better at writing cleaner code. It can also happen because we didn't care, or because the team didn't care. Not caring can also be due to lack of knowledge, but it can also be due to like, I want to do my job, I want to like add this feature and that feature and go home, and not worry about clean code. The thing is, more maintainable, cleaner code allows us to work faster, to include our features faster, and maybe go home a bit earlier. It can also happen because we have to hurry, because we have deadlines, because someone tells us just make it work, we don't care about how the code looks. But that will bite us later. So if we had deadlines and we had to ship something, we still have to clean it up as soon as possible afterwards. So we have to make it a team decision that we want to clean up the code base, where we want to clean up the code base, what we want to achieve cleaning up the code base. That does not only include the developers, that of course also includes management, because cleaning up the code base, refactoring and adopting new team habits takes time, it costs. But on the long run, it costs less than slowing down more and more and not being able to do the actual features we want to do. Everybody has to be aware of the costs. For example, that at first when you start to adopt new habits, and when you start to do more code reviews, when you start to do refactorings before you check stuff in, it will cost, and everybody has to be aware of those costs. Do not raise false expectations. If you just say, yeah, we write just clean code from the get-go, we don't have to learn anything, we just do it. people will get frustrated because they realize they're going slower, and they have to expect to go slower in the beginning. So we said people maybe didn't know, didn't care. This is what we could call like legacy knowledge. The team might not have read the book about clean code. They might not have heard the term ever. They may not know about refactoring. They may not know about new language features, about how you can think differently. So we have to start to learn as a team and care as a team about the code base. That can be done via trainings and workshops, which can be costly. Trainings and workshops either done by internal people who know this stuff or getting external people to actually give the trainings. This can be done by in-house presentations. I've learned about a lot of developers and teams who do like a weekly or every second week a 1-hour presentation, maybe during working hours, maybe even during lunch hours. Depends. You can do it by writing wiki or blog articles. That's what I started back then when I was in that situation. And you can also write just informative emails. I've been in a team where one of the team members were just every Friday they would write an email with just a collection of links to blog posts or conference videos or something that was of interest to the topic they were just dealing with that week. So doing this will help the team grow and build the knowledge they need to write that cleaner code, to write better structured code, and to write maintainable code. We can also practice and learn together. This includes pair programming. I mean, if you have like a team of people who all have more or less the same level of knowledge, then pair programming will give us a bit of quality. But if you have a team of people where they have different knowledge, either about the domain or about the new standard features or cleaner code techniques, then you actually can learn a lot from each other by just sitting beside each other and talking about the things you are just doing. A bit of the same can be achieved by doing code reviews. Code reviews also can help us to not fall back into the old habits we had before. If we have like for 10 years done things the same way over and over again, and suddenly we try to change our habits, that's a really hard thing to do. I mean, I don't know if any one of you ever has tried to change a habit they had for a decade or longer, but it's a hard thing to do. It takes time. And it's good to have someone look at the things you do and say, well, that's something you wanted to avoid, you wanted to do differently. When we are doing code reviews, we shouldn't just blindly search for something to criticize. I've been in a team where we introduced code reviews as part of the process before checking in or after checking in. Before merging, we did code reviews. And some people didn't really think they did that about what the code reviews were for. They didn't really want to do code reviews. So all they did was just go through the diffs. And when they found something, they pointed out that something and sent the code review back. I've reviewed a part of the code and I've given you something to improve, and that's it. That's not how code reviews work. Another way to practice and learn together are coding dojos. You can do them do just little practices on the side. Of course, it also takes time, but it also builds the team together. It practices writing clean stuff from the get-go, because writing cleaner code in a greenfield kind of situation is much easier than seeing old code and trying to imagine how it might look if it was written clean. Of course, instead of pair programming, you can also use mob programming, where one is the programmer and the rest of the team watches or guides them to do the programming. It's also about building awareness for code and habits. So build awareness for code smells. Things like don't write extra long functions, don't write functions that take like 20 parameters or something, things like that. Awareness for refactoring opportunities, like these kind of low-hanging fruits where you can, like, with a few little changes, improve the code visibly. And also, what's also needed is awareness for the right amount of time we spend refactoring. Because if we are in such an old code base, we can very easily, in a task where we have like half an hour of work for an actual feature, then go off and start a refactoring session that lasts days, weeks, more. So we have to find the balance between adding new features and actually earning our money, because adding features, fixing bugs is what earns the company money, and improving the code base. As I said, changing habits is hard. And not everyone wants to change their habits. So depending on the team, depending on how long the team has been left on for themselves to do the things they have done as they have always done it. If someone comes into the team and tells them, yeah, we should do things differently, you're going to meet resistance. Especially if there's someone maybe in the late 20s, 30, and having like 4 or 5 years of experience and meeting a bunch of developers who have like 10, 15, 20 years in the field, and she starts to get to them, yeah, we should do things differently. You're doing things wrong. You're writing bad code. We should write cleaner code. This is not a good way to go. This immediately raises like, no. You want to tell me I have to change my habits? No, just no. So it's really hard to go against this, to do things right, to persuade developers that actually cleaner code gives you a benefit. It will also, yes?
Isn't the language you use here important? You don't tell somebody that they've written bad code. You ask them, have you considered doing it this way?
Sure.
So I think you can avoid a lot there.
Absolutely, yes.
Just clever choice of words.
Yeah, clever choice of words goes a long way, but still, in the end, if you ask them to change habits, it's still going to be difficult for some and a no-go for others.
Yeah,
It's
you don't ask them to change habits, you get them to do it themselves. Which again,
yeah,
it's
absolutely. So the comment is, you don't ask them to change habits, you get them to do it themselves, but you need to do the right persuasion to do this, of course. There will also be resistance from management. Why should we invest like 20% more time or so to do refactoring and so on? It has worked until now without. So, as I said in the beginning, it will be slowing down the team, slowing down the development, and the speed up you gain from a more maintainable code base will come later. And it can be sometimes very hard to persuade to the management that this will actually pay off at some point. Of course, also working slower in the beginning means maybe delivering less features or something. So we will also have other stakeholders who might be against those short-term losses. What we see very often is, that's my code. I mean, if you have a code base that is hard to understand, you might have 1 or 2 persons for a given piece of code who know this kind of code, who have been in this code for a year or 2 or 5 or 10, and others who say, well, that's just complicated code. I don't know that code. I give all the work to the code base, to that part of the code base, to that one developer. And when suddenly you come with the idea that, well, everyone should be able to change every part of the code base, and we want to refactor all the code base, we want to apply changes to that part of the code base, then people might get a little, well, might think it's a personal thing. That's my code. I have written this code. Nobody touches this code but me. And I've written the code the way it should be, and it's again something to overcome, to persuade people that having their own part of the code base is not a good thing to have. That being able to work in every part of the code base is better for the team, is better for the code base, and maybe also better for them. We don't have to apply those changes from one day to the other. It has to be a slow process so people can ease into it, and slowly changing habits is easier than just quit smoking from one day to the next. What I've also heard often is, yeah, that's my code, it's too complicated to test because I'm the smart person. It's not too complicated to test. It's maybe very complicated to refactor, but with a little help we can refactor the code so we can get it under test. Something else I've heard, leave testing to the testers. I mean, cleaning up the code base is about refactoring the code base. For refactoring, we need tests. We have to write tests for our code base. And in that one particular project, we had like manual tests, we had UI tests that were programmed by testers, and we had like a very thin layer of system tests, and that was it. For refactoring, you need unit tests. And the concept of a developer writing tests, writing unit tests, is something new to some people. In some shops, you have like the clear distinction between we have developers who write code, we have testers who write tests, or who manually test the code base. So after you've tried to persuade everyone, after you really put in your best effort, one of the questions I get very often is, what do you do with those who still resist, who can't be persuaded? That's a very hard thing to have, because leaving them in the code base and keeping them basically working against these efforts can ruin the whole thing. Because one person can well, destroy more clean code effort than two persons can restore, can clean up. So you either have to try to continue persuading them. Sometimes you can maybe reassign them to a part of the code base where you are not refactoring in right now, or sometimes other teams. I'm no expert in team management, but this is something that has to be dealt with, because if not, this can be very frustrating for the rest of the team that actually tries to clean up the code base and is worked against by single persons. In some cases, you might get the feeling, well, there are only bad apples in my team. Nobody wants to do those changes. I've talked yesterday, I think, or the day before, with a young person who said, well, I really want to clean up our code base, but nobody in my team wants it. My managers don't want it. My team doesn't want it. They just want to keep going like they did the last 5 or 10 years. This is a clash of cultures. And if the whole team has a culture that contradicts your own culture, I mean, there might be one solution, that it's not the right team for yourself. That's something you have to think about. If it's like split in the middle, part of the team has to wants to do those refactoring, the other part of the team doesn't want to do those refactoring, then you have a conflict that has to be solved. But if you're the only person or one of two persons in a larger team that wants to actually do something and nobody wants to do it, then, well, you can't play the dictator in your team and say, well, we just want to do it now. So either you just give in and don't apply those changes, or you find some team where you can do this kind of thing.
But can't you approach it in a slightly different way? Can you, in any part of the code you touch, clean that up? I adopt a Boy Scout rule.
Yes, Boy Scout rule is part from that, but
and hopefully that will spread then.
it can. But it can also mean that you clean up part of the code base and the next day someone else touches the code. And I mean, it depends on how quickly you want to see things go. In that one particular team where we had people like that, it was like, yes, we clean up parts of the code base. My manager said, yeah, do the cleanup things. If it takes a little longer in the beginning, we will get those gains someday. Other developers try to do those cleanups as well, but we had like a bit more than half of the team was like just not caring and just keeping on copy pasting all the old stuff and things like that. And it was just so frustrating. We had like a huge refactoring thing where we wanted to get rid of our compiler. We couldn't get rid of the compiler because it was bound to the UI framework we had. We couldn't just switch the UI framework because all of UI classes, of course, had hundreds of lines of business code in them. So we started to create a little architecture where we did like a model view controller separation of all the UI classes. And it took us 1 year to actually split a little more than 10% of the UI classes. So we had like 9 more years to go to split them up and then replace the UI. But the problem was when we had done that 1 year later, in those new UI classes, suddenly new business logic started to appear in the UI classes and not in the controller classes. So it was really frustrating. And that was actually one of the reasons, the point in time where I said, "Yo, it has no use. We never will get there." So I actually changed teams. Of course, besides coding habits, there's also processes, estimates. We had a very common task where something similar would occur like once or twice a week. And in those processes, the business analysts estimated our tasks. So we would get the task, yes. We would get the task estimated to be half a day. And 5 years before that, half a day would be a good estimate. But due to scope creep and the code getting worse and worse, at that point in time, those tasks would take like 2 days, maybe 3 days. So these old processes, the things we have done all the time that have to change, don't only include the code base, but also like processes, how we deal with teams. I'm not saying we should like from now to the next day should go full agile or something, but try to apply some processes that make the refactoring thing easier, especially if at the beginning you don't know really how much the slowdown will be and how much the speed up will be later. So I think the more important part of the changing code bases or cleaning up code bases, that it's about people. It's about tech too, but you can fight the tech and you can start to improve the tech, but you cannot fight the whole team, you cannot fight the people. Any questions, comments so far? Okay. Yeah.
I took my manager to say, okay, we start allocating 20% for bug fixes, 10% for fixing technical debt.
Yeah.
That was a huge milestone because at that point I could just schedule, okay, we're going to this, to fix whatever problems we have in the legacy parts.
Yeah. So the comment is you got your manager to allocate not only 20% for bug fixes, but 10% of the time for technical debt, for fixing technical debt issues. Yes, that's a really huge step because, I mean, even if the whole team wants to fix things, if the manager doesn't approve, it's not worth anything. So getting like this 10% of your time is really a huge step. Was it your time only or time of the whole team?
Time of the whole team, but it also meant that, for example, during sprint reviews, we should touch on the topic because we have to explain, okay, we use this 10% for this. So it
Yeah.
again gained recognition, gained
Yes. So 10% for the whole team is a huge thing. And as you said, touching the topic in sprint reviews is a good thing to build awareness as well. And maybe even, like I said earlier, these like little presentations in-house in team, you can show in your team, the whole team, what has been done, so the team can learn from the improvements you've made. So the team can learn as a whole to actually use these new things. Because if someone just improves part of the code and the rest of the team doesn't really know what the improvement actually was, they're going to use their old techniques. So I think this is an important part of that as well. Yeah.
We recently joined, the last 8 months, a new company that has a very large legacy code base. It consists of 5 main components that are really tight coupled, and it was pretty much impossible to have new features without breaking something. So this is my manager. He approached his manager to get us 3 months, no new features, 3 months to tidy up the code base. We used that time to do some tidying up. We also invested that time in training. One of the comments earlier on was give talks and so forth. One of the things I do is I send out a conference video every week of some useful topic that will help people improve their code. So we've introduced unit testing. We're educating people about why they're important. And people are now getting little light bulb moments coming through code reviews because we're reviewing their code and we're getting them to review our code. And we got a nice, simple comment from one guy a couple of weeks ago. He basically said, there seems to be a bit of duplication here. Can't you move this around so that you can remove that duplication? I said, well, you tell me. He said, you've got a complete set of tests there. Have a play.
Yeah.
So he went, oh yeah. He says, you wouldn't have been able to do that without those tests.
Yes.
You know, so he's had a little light bulb moment now, and suddenly he's writing twice as many tests as he used to do.
Yeah. So the comment is, I have to edit for the video in short. You got into a new company and you basically got your manager or your manager's manager to allocate like 3 months of complete feature stop and complete, refactoring, improving code bases, training the people to, and actually got your team to recognize that, for example, having more tests is a good thing to actually enable you to refactor, right? Okay. Thanks. Good. So, you got the team together. Let's start refactoring. I think this is a definition from, Wikipedia. Refactoring is a process of restructuring existing computer code without changing its external behavior. So, in short, working while getting nothing done. I mean, nothing visible at least, for the outside world. It's a cliché, but it has a point. we have to make sure we actually get something done. I mean, you can, if you have your manager and the stakeholders allow you to do it, you can allocate like 3 months for doing nothing visible to the outside world and just refactor your code. It gets visible later, of course, when you have like faster development, but this is something you have to keep in mind when talking to managers, to stakeholders, and so on. Good refactoring is the key to legacy code. I mean, we can do test-driven development, not in legacy code, because we need tests first. When we write a completely new part of functionality, we can use TDD, hopefully. If you have new and small code bases, then refactorings are small and controllable. If you have like a huge code base and maybe some utility class that goes through all of the code base, starting to refactor that utility class can get you down a rabbit hole you never come out of. I've at one point seen a iterator class that did not look like a C++ iterator at all, but like a Java-style iterator, like if next, then get next, and so on, this kind of loops. And of this class, the iterating part was like 10% of the code. The rest was, of course, business logic. So we tried to refactor it. We were like 2 people who took a little over 2 weeks to at least start to refactor the thing. It was really a big problem because we had to touch basically all of the code base. And in the end, when I wanted to merge it back to the main branch, in the morning I told the team in the stand-up, yeah, we are going to merge this afternoon. And after the stand-up, one person came to me and told me, I'm really glad we are getting rid of those Java-style iterators because I find those C++ iterators so cool. And I was like, yes, someone really appreciates the refactoring we are doing. At least someone tells me. And at that day, when I tried to merge, I got a bunch of compile errors because at some point in the code after the merge, something was using those old iterators. That very person, after talking to me, had copy-pasted one of the old classes that was still using the old iterators. So we want to plan our refactoring. We want to not go ahead and just start somewhere and see where it leads us. We want to plan our refactoring. The question is, where do we want to start refactoring? We don't want to refactor in some part of the code base that is maybe old, maybe looks ugly, but is never touched. Something that just runs under the hoods and has been running for years and has no problems. There's no need to actually refactor this, even if the code looks ugly as hell. So don't at first touch code that is good enough for whatever good enough means for now. That is bad, but never touched. Code that you are not sure about, because again, touching code that you are not sure about, you have no idea what the risk will be actually refactoring the code. Code that you can't test sufficiently is also a hard thing to start refactoring because, well, without tests, you don't know if you break anything. So where do we start? There is a very good book by Adam Thornhill called Your Code is a Crime Scene. He's also blog posts with this title. There are also conference videos of talks from him with this title. He basically applies criminal science to a code base to figure out where the changes are, where are the hot paths of your code. Basically, you run a script over your Git repository or your SVN repository, your version control system, to see which parts of the code get changed most often. Where do we fix all our bugs? Where are the problems? Where are the sources of our bugs? because those are the parts where refactoring and cleaning up the code base really pays off. The code base where everyone has to read it every week. If you clean that one up and speed up the reading, you have already gained something. Fixing something that nobody ever touches, who cares? Yep.
How will you identify the code that everyone must read, and can identify a code where everyone must change as they read?
So it's about the question is how can we identify the code everyone has to read, but that no one has to change, basically. Usually it's in the same area, so you don't go for single files maybe, but for components and things that are attached. Sometimes, sometimes you know from experience, if I have to touch that file, I have to understand that other file. I mean, this is not a extremely perfect science, but this finds you the files that are touched most often. And you can do things like grab on the file which names are used most often in the file. So those names, those classes are probably related stuff you had to better look at as well. But I would see that as probably as a second step, because the files that are touched most often, you definitely have to read most often. So in general, this is more about seeing where I have to clean up things instead of finding the most dirty place. I don't know about you, but in most apartments, the most dirty place is below the kitchen cupboards. Nobody ever looks there. And they're probably sealed off a bit, and what's behind a cupboard, if there's dirt, well, nobody ever looks there, nobody has to care about it, but the place where you walk every day, you probably better clean it up. So now we know where to refactor. We still have a lot of code, and we still have only little time, so we have to pick a goal, what to refactor, what do we want to achieve with our refactoring. Generally, main pain points can differ from place in the code, between the different places in the code, but very often if you have like one of those files that are touched every week or so, then certainly some of your developers can tell you, yeah, every time I open that file, I have like this weird thing in the corner where nobody really knows what's happening there. So that might be a point where you can really clean up the code base, and so people know what's actually happening there. We should keep aside cosmetic refactoring for now, because, well, going ahead and cleaning up the names in all of our codes, well, it certainly helps something, but it's not really the big pain points. It's not really the biggest problem. People get used to the names, even if they don't exactly say what's behind them. You can clean up those names as you go if you have like, you are working in these places in the code base, but if you have like a targeted refactoring to actually improve one specific part, those cosmetic refactorings won't help you much to get to that specific code. No sidetracking. This can be very hard if you are on a refactoring spree, like, I want to fix this. Oh, and there's this problem as well. Let me just fix that. Oh, and there's a missing const, and I fix the const, and you get like tracking the const down through all the code base, and a few days later, okay, where was I going? Oh, I wanted to fix that primary problem, and then you start again. So try to not get sidetracked, go towards that goal, and if you have fixed the goal, you can pick the next one. Maybe take notes, oh, there's a missing const over here, I should fix that later. Especially if those are big refactorings you are starting, we should either time box it, do smaller refactorings at a time towards that goal, and not try to do all of it in one session that can maybe take 2 weeks, 3 weeks or something if you don't have the time allocated for it. Or just narrow down the goals so you can achieve it in one refactoring session. So what could those goals be? More automated testing or automated testing at all. If you don't design our code for automated testing, it's maybe hard to get automated testing started. So we probably need to refactor to get those, to enable us to test automatically. This should be one of the first goals, because we have this problem: if you don't have testing, we can't really refactor without having the risk of breaking things. But if you don't refactor towards testing, well, we can't really test. Of course, finding bugs, fixing bugs. If we have more tests, better tests, then of course the tests will find.
Less bugs is the goal. Automated testing is the means of achieving that goal, isn't it?
Yes.
I think less bugs should be balanced. I think that's the reason.
Depends. If I could live with a few bugs I have until now, then probably a bit more time having those bugs is not that bad. But of course, the automated testing also enables us to really start the refactoring towards fixing those bugs. So I would put testing as a first priority, and then either the tests already find also bugs, or they enable us to fix the bugs.
I think that, as I said, when we did our major refactoring,
yeah.
The biggest benefit we got was fewer bugs.
Yeah.
We found literally hundreds of bugs that nobody knew even existed.
Yeah. So the comment is that in that refactoring period, in the 3 months, you found the bugs through the testing, or by looking.
It was a combination.
Yeah.
But our real goal of doing all of this was to have fewer bugs now and in the future.
Okay, so the goal was having fewer bugs, and you did testing and bug fixing in parallel. Yeah. Yeah. Okay.
Can I have a question?
Yeah, sure.
You were talking about the bugs.
Uh-huh.
While at the beginning of the presentation, you had mentioned that the refactoring is the changing the structure
Yes.
without changing the behavior.
That's right.
The bugs is changing the behavior.
That's right.
Should we mix it up?
Yeah, I don't think we should mix it up. So very often it is hard to fix the bugs we have without cleaning up the code base. So what we can do is first refactor it, only refactor it, and then as a second step, when you have refactored and enabled us to actually fix the bugs, then fixing the bug is another step. It's not part of the refactoring.
You refactor, have the tests, find the bugs.
Yes.
From my experience, sometimes a bug is a feature.
Okay, sometimes a bug is a feature.
This is known as Hiram's law. It's Titus Winter's called.
Yes and no. The bug is obviously not part of the requirement, or else it wouldn't be a bug. Bugs are often used as features, yes. Especially if you are going like to gaming, you have like glitches, things that shouldn't be happening, and they're used for speed gamers, so they can finish a game that normally takes 20 minutes in 2 minutes, because they just go there, glitch somewhere, and are finished. Yes. Okay, bugs as a feature, I don't know about that. Of course, some goal can be faster development, where you can refactor something to be easier to add new features, to add new stuff, instead of having to write everything from scratch again and again and again. You just refactor and maybe factor out a framework or something where you can just add the new features. And new features take less time to develop, less code to write. Well, more readable code is, of course, leads to faster onboarding because people that are new to the team have a less hard time to get through the code, to understand the code. Shorter compile times can also be a side effect of refactoring, or you can have it as a goal and say, well, we want to decouple our classes to be able to actually have like single little translation units and not have to rebuild the whole world whenever we touch something in our code. Scaling architecture is also often a problem. I've been in a project where we had like the whole application was about creating forms, and it was originally created, and the original architecture was created for maybe 10, 20 forms or something. And then they had a slightly different use case, and they thought, well, we could use that old software for that. And they started to apply the new use case to the old software and added forms and forms and forms. And in the end, we had like 500 forms instead of 10 forms. And the architecture just wasn't made for it. So we had to basically refactor the architecture, re-architect the whole thing to actually make it scalable. Separate refactoring from daily maintenance, meaning you can do it on the same day, meaning doing a refactoring, doing a bug fix, doing a new feature, but we should not, if possible, not do basically check-in like hundreds of lines of refactoring and that 2-line bug fix in one check-in, because no one is going to see the single bug fix and no one is going to see what's happening actually. So separation of concerns or single responsibility principle also is applicable to commits. So have one commit for refactorings, have another commit for bug fixes or new features. Sure, you can't. A code review is much easier if you have like, yeah, this is one bug fix, 2 lines of code, and this is a refactoring where you have like to look with a completely different view on the code. Yes. And sometimes people have a hard time to see like this huge refactoring includes that I have to fix that bug and that I have to change that and that I have to apply a slight behavior change in this place. There are techniques to make to break up large refactorings into smaller steps. Sometimes it's just, well, I have to go from here to there, so I rip it all up and then I stitch it together again to get here, which is like a huge refactoring which can take days or something, and in between I don't know whether I've broken something, where I've gone, and when I stitch it together like 2 weeks later, I have the problem, yeah, some of my tests are broken, maybe something doesn't compile, and I have no idea which part of the 2 weeks has broken the things. So I can apply techniques to make the little steps, maybe not in the direct direction, but go a way around in little steps and always be in the green, always have like running tests, and get to the point where I know, to the point I wanted to go to. And if in some point in between my tests break or my compiler won't run anymore, then I know, well, this small thing I have done in the last 10 minutes or in the last hour, that one has broken the test and not the thing I did yesterday. So, safe refactoring needs tests. Unit tests need modularization. Modularization is achieved through refactoring. So how do we get started? The first thing is integration and system tests. I can test my system as a whole and then have some security that I don't break everything. The other thing is to have, well, there was a talk by Claire McRae in CBP on C where she talks about approval tests, which is basically a framework where you have like minimal intrusive changes to your system, where you have maybe add like a command line or text input output to your system, and then you can record the inputs and record the outputs, and the framework will basically replay those inputs again and again and check that the outputs stay the same. So this is a kind of pin down test on system level. On the other hand, you can start with small and provably correct steps. Those are tedious to prove that they are correct, and they won't get you very far, but they will get you started. Of course, there's no guarantee they don't break anything, but if you can prove that, for example, switching the if condition and switching the if and the else block, well, this won't break anything. And those very small steps might get you to some point where you have like the opportunity to start with the overall testing. So start with large-scale decoupling. First bring the whole code under test, break out a smaller piece, bring that one under test, and then break it down and until you get down to unit tests. And having unit tests gives us the ability to do all this small-scale refactoring where we can be more rigorous, where we can be where we don't have to be that careful because we are secured by test that everything we do is not breaking our code base. So we also can have yes.
Adding to the previous slide, maybe slightly understood, but when you contribute new code to already existing code base, you can already apply the rules that you set, like adding small tests from the beginning on.
Absolutely. So the comment is when you write new code, you should immediately also write tests for it. Sometimes you add new code to a part that is not really broken up into small parts, so you have like still the big part, but still you can write bigger tests, system tests, acceptance tests, whatever component tests to pin down that new functionality you just wrote. Yes. You can have approval tests for components where you have like, I have two components that work together, basically drive a wedge between them and add a little interface to the lower component, I would say. And then you can basically record what data is passing through the two things. Make an interface for a class, use that interface, and you can wrap the class, and then you can track what function calls are executed with which parameters. And if you have those recordings, you can replay them again and again, and that's kind of a new test for your component. If you have like this historically grown spaghetti code, sometimes also called big ball of mud architecture, if the architecture hasn't been refactored and your classes in different components are entangled with each other, then at some points you don't really have those original components anymore. But if you're looking at the code and you see this is namespace A, this is namespace B, in your mind they are separated, but in reality they aren't. So you have these misleading namespaces, misleading package names, and so on. What you can do then, which at some point is a bit scary, is complete the mess and make it one namespace. Because in reality, it is only one namespace. This is one thing I have done where I've discussed with my team. We have like a bunch of it was like 5 different namespaces, 5 different packages. And basically in every CPP file we had, the first thing we were doing was like using namespace A, using namespace B, using namespace C, using namespace B, because they were all entangled together. So I said, well, those namespaces are a lie. Those are not really namespaces. Those are arbitrary names. So we just, one day on a bank holiday, I went to work and I sat down and I was just with regex replace, make it one big namespace. And it didn't hurt the readability at all because, well, it was one big wall of mud. It was no clear structure. But after that, we could go ahead and reassemble the thing. We created new namespaces, and we allocated the things that clearly had one use to one namespace and another use to another namespace. So we had our big legacy namespace, and we were separating the things from the legacy namespace and moving them into the new namespaces to actually have real components again. Very often people say, well, you could as well rewrite instead of refactor. This can be an option, but there are pros and cons. And what we should do is, or what often is a good thing to do, is having the new components rewrite parallel to the old components to replace them bit by bit, and also be able to see if the new components behave like the old components, especially if we are adding new features at the same time. We have the double work to the old component has to have the new feature, and the new component has to have the new feature until the new component is actually ready. Cons are, well, if the old component has grown over 10 years, there will have been a lot of errors, and we will have fixed all the errors. If we write the same functionality with a new component, there will be a lot of errors, and they all will have to be fixed. We have the double maintenance, and we have to first decouple the first component, because a component that is really highly coupled with the other components around it. You can't really write a replacement for that. The pros are we can start with things, clean code practices right from the start. We can start with test-driven development and write really beautiful code and really well-tested code from the beginning, and we don't have to break up the old component to actually bring everything on a test and refactor it. We can use completely new techniques, maybe have a DSL or something, but well, we have to weigh the pros against the cons. Now, about tooling, many IDEs, modern IDEs, have built-in tooling for refactorings. If you see, like, for C++, that's, for example, Visual Assist X, or the JetBrains tools like ReSharper, ReSharper++, CLion. For Java, we have IntelliJ. All the Java IDEs have good refactoring tools where you can, like, well, factor out a function or rename this function in the whole code base, change signatures of functions. Those tools are getting really good, also for C++. What else do we have? We have static analysis that can help us find, like, the usual suspects that look weird, where we have, like, can fix things like accidental assignments in if conditions and stuff like that. And we can have other refactoring aids that really help us to improve the speed of our refactoring. The problem is, especially on the C++ side, if we are using an old compiler because we can't get rid of it, and we have old IDEs because they are bound to the compiler, we don't really have those tools at hand. So what we can do is consider using a new IDE and a compiler, but it's not that easy. For example, switching the compiler, sometimes we have to refactor to be able to do so. Some compilers in our code base, we may be using, like, old C++ extensions from the old compiler that the new compiler doesn't have, so we have to get rid of those extensions. In that project where we had the UI, we had to get rid of the UI framework and do a lot of refactoring to be able to do so. Usually those things are smaller refactorings, but especially in the case of that UI framework, it was a really big refactoring. Now, what we can do if we have those old compilers and no actual tooling that can help us with refactoring, we can get help from the compiler. For example, when we rename a function, the compiler will tell us, well, it will point us to every call of the old function name because the function won't exist anymore. So just rename the function in the header and start the compiler, and we will get a list of all the locations where the old function name was used. We can use override and final, especially if we are dealing with when we are dealing with virtual functions. We can use stronger types, like wrapping types in structs. We can, of course, try to use the warnings and errors the old compiler will give us. And when we have maybe a new language standard, for example, let's try to refactor a function. We want to get these first 3 lines out of this function. So the first thing we can do is just add braces. Now the compiler will tell us, well, new node, I don't know what new node is because new node is only defined in this new scope, and we will get a compile error. So we know the new function returns the new node. So we make it a lambda and say new node is called create node. We have to catch everything that is before the scope by reference in the lambda. So the next thing we can do is remove that reference. Now the compiler will tell us I don't know what data is, because data is not in the scope of the lambda. So at this point we see, okay, so data has to be a parameter of the new function. And when we have done that, we can just take the lambda and make it a free function. And this is all by help of the compiler. Of course, we can also refactor a bit because, well, tree data is not really used. What we want to use in the thing is root data, but this is like a little manual refactoring later. But this is like step by step with a little help of the compiler telling us what we have omitted or what we have forgotten. So, clean code for large-scale applications. It's a very costly and a very long-term project. Can take a year, can take 2 years, 10 years, no idea. Can be very frustrating. On the technical side, the most important thing is having tests. Because without having tests, you can clean up the code base and break everything. And as we had before, in Bjarne's quote, the legacy code works. And a working legacy code is a better alternative than a clean, not working code base. But what's even more important to actually get this project started is having the team on your side. And stakeholders, of course. Yeah.
I agree with the long term. I'm not quite so sure about the cost later. I think that there's a high initial cost, but you can start to get payback very quickly.
Well, what you are doing with with cleaning up the code base is basically paying back the technical debt you've accrued in the past. So that payment is costly. At some point, you will get back the speed of development, and you will get the cost back.
I think the important thing is focusing your efforts on places, as you said, that
Yep.
change the most.
Yep.
Because once they're cleaned up, you can develop those parts much faster.
Yes.
So you gain the benefits back very quickly there.
Yeah. So the comment is fixing the hot path and cleaning up the hot path will give you back the benefits quicker than in the other parts. Yes.
And that helps to mitigate the
But,
costs very quickly.
okay, so in the short term, it's costly, and you gain it back in the long term. But it still is a long-term project, and you need to have the patience. The team needs to have the patience. Customers need to have the patience to actually see results, positive results. Any more questions, comments? Yes.
Have you ever encountered the argument that you cannot change, like refactor or reformat a code base because you would screw up the version tree, that file code base?
Have I ever heard the argument that I cannot refactor or reformat a code base because I would screw up the version history? I have heard the argument that I shouldn't clean up indentation and so on because it would just be a white space, but the files would look like completely different. I mean, the same argument can be made. You shouldn't add a new functionality because the file will look different, right? So, but refactoring, if the only argument against the refactoring is the file will look differently later, then I think what you gain from the refactoring is the best counter argument. I've heard it, but it's a con. Of course, you have like the file won't look the same, but you won't have any added functionality. But
Not so much about how it looks, but
yeah.
you cannot SVN blame the last one who changed that line because it might have just been refactoring. Yeah.
Okay, you can't blame SVN blame or Git blame or the one who has added the original functionality because someone changed it. Well, my answer to that is Git blame is good for asking someone what the functionality does, but blame is really a bad name because the file belongs to the team and not to someone specific. And that's what code reviews are for, to get the code someone has written and as a proxy for the team, accept it for the team, and accept the responsibility for the team. I think that was the first comment.
So, I've run into your situation as well. That was in a team where every commit was a feature. So, they wanted to just do, okay, here, ridiculous system. Give me the last, all the revisions up to then. Hey, this is my change log. Release notes are done. If you do refactoring correctly, you're totally breaking that approach. But this approach is totally random. So the first thing I did when I joined the new project is just to fix the commits, all taking smart minor things, and that story was this.
So the comment is that claim comes often in a culture basically where every commit is a feature, and if you actually start, which is bogus because you can't refactor in that culture, and if you actually start to do refactorings, well, not every people won't assume that every little change is a feature anymore. Yeah.
He said exactly what I was going to say.
Okay. Yes, first.
Another problem with that is that actually in our code base, for example, people would go and say, okay, we have to fix some or do some feature in a version of this product as custom or version has, and then the feature would be merged to all newer versions. And of course, the point of view factor that you would have to look into that and all of this. Yeah, they would also always complain, hey, this is just the refactoring, and now I have to change my features and do also merge zero of them. But I think this is of course, if you continue this line of thought, you can never make everything true.
Right. So the comment is, if you have like old release branches and you have to add new features or bug fixes to those old releases and to the current main branch or something, and you have refactored the part in between, you have to basically, you can't not simply backport it because you have to undo or redo the refactoring on the new feature. Well, yes, but as you said, with that argument, you can't really refactor anything, and you're back to just add new features, and not change your code ever. So this is a pain point, but in the long run, hopefully, you will be at the point where you don't have to like add new features to the very, very old code base, and you are past that point. But it may be a cost that you have to keep in mind, that basically you have to write new features in the part you refactor it twice, or the features for old releases, one for the old code base, one for the new code base. Yeah, Gareth.
When refactoring format and to show the behavior that you want
Yes. So refactoring code should also preserve the performance characteristics, right? Yes, it should. But again, we have to use a profiler to determine whether we are on a hot performance path, whether we have to preserve performance characteristics in that part, and we should measure later whether we have impacted performance or we didn't. So that shouldn't. So refactoring in a part of the code base that is performance critical shouldn't be a no-go. We should be careful with it, of course, but just saying, well, this is a performance critical part of the code base, don't touch it, is not an argument. My iPad just went blank, so I have no idea how much time I've left. I think 5 minutes. Yeah.
I've never ever been in a company where people say this is performance code, where they also had tests proving that it was performance code. If they had performance tests, nobody was ever worried about breaking performance.
Yeah.
So it's odd that the two that feel like they should go together always go counter to each other.
Yeah. So the comment is, you've never seen a code base where someone said this is performance code where there was actually performance tests. So basically, we could fix this by having non-functional tests, having performance tests, which would also include, well, in the performance characteristics while we are refactoring. Yep.
Do you know of any studies that have been done into technical debt that we could possibly use as ammunition against or to show management, which is often not understood?
Yes, do I know of studies towards technical debt? I do not. Code Complete. I don't actually know whether Code Complete has studies about technical debt or links to it. Yeah.
Studies, isn't it? So there's bound to be some in there. I'll bring them on Monday.
So, but I don't know whether Code Complete actually touches refactoring that much.
But it will talk about debt.
It will talk about it. Okay. Yeah. 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 Sure. So maybe in Code Complete there will be links to performance studies, but then again, or to technical debt studies. But then again, I mean, Code Complete is like from the 80s, early 90s, I think. It's early 90s, but yeah.
We haven't changed. The studies still hold.
Yeah. Yeah. Yeah.
Something related to that is you can try to make something with data you have. For example, what happened in my company, I kept flashing to red because they were only doing manual testing, and I was like, okay, show me what you do and tell me how long it takes. I was like, yeah, okay. They show me all the tests, and like 90-95% of tests could be easily automated. I was like, so you're losing X amount of time because instead of pressing a button and letting the computer do the work, you're doing the work. So if you can quantify that and go back to management, you don't need like a general thing, but you can all have data that is tailored to your situation.
So this is a very good point. If you have like many manual tests that can be automated, automate them, and you have a good test suite for your developers also to pin down their behavior. Yeah.
In our company, they have automated tests, but they're regression tests. So what happens is the developer checks in here, eventually it gets merged to default, and then it goes through the regression suite, and 3 weeks later they get told about the bug. It's by adding unit tests that happens 2 months later.
Okay, so that comment, I think this will be the last comment because we're running out of time, is that if you have like long-running tests or a long test pipeline, then it can take weeks until you actually get back the long-running tests or the results of those tests. Yes, I mean you have this problem when you start when you start the refactoring stuff, but it's still better than no tests. And of course, that's why I put the getting things on an automated test first. So getting things on a small automated test that can be run quickly is really important to get this early feedback, to get the fast feedback loop. Okay, last one, Arjen.
Just very short. I have a study from 2003 about technical debt that does some research into this. I'll send it to you.
Okay, So there's a study from 2003 about technical debt. Okay.
So quite a bit more recent than Copenhagen.
Good. Thank you very much.